Good morning, everyone. Welcome to this webinar, How to Design a Future-Ready SOC, Staying Adaptable and Agile in the Face of Change. I'm Amy Perez, Head of Marketing and Communications here at Adarma. This webinar is part of a three-part series based on our latest report by the same name. You can download a copy of the report by clicking the link that Ariana is kindly going to pop into the chat window. Part two of the series is taking a look at data pipelining and how you can more effectively manage large data volumes to reduce ingest, processing and storage costs. While part three delves into how to stay future ready through continuous posture assessment and the purposeful adoption of AI and machine learning. If you'd like to register for either parts 2 or 3, you can get links to those in the chat just in a moment. Ariana will post those in. Today, I'm joined by James Todd, Chief Technology Officer at Adarma. James is going to talk through the architecture playbook for designing and building a SOC that tackles today's challenges and is adaptable and agile enough to prepare for future changes to the threat landscape, the technology market, or the business you protect. We'll have time for Q&A at the end, so if you have questions along the way, please type those either into the Q&A window or the chat. And with that, I'll pass over to you, James. Thanks very much.
Thanks, Amy, and good morning, everyone. As Amy said, we at Adarma have defined what we believe to be the blueprint for future-ready security operations, particularly the adoption of technology and technology within an architectural pattern for future-ready SOC. So we deliberately calling this future-ready, not future-proof. Nothing is future-proof. So these are principles that we believe that organizations, no matter who you are, whether you're building something in-house, selecting a third-party service provider, or ourselves as Adarma building managed services and platforms that support those managed services for our customers. We've got a fairly packed agenda for 30 minutes of me talking, and then hopefully 10-15 minutes or so of Q&A from yourselves. So we're looking at the journey so far, where we've come from a SecOps capability point of view, the challenges that we face with traditional SOC design, the sorts of things that a future-ready SOC should include, looking at open architectures and addressing some of the principles at a high level that we'll come on to in future sessions, the second and third webinars that Amy mentioned. So those being data acquisition and storage, federated detection and response, continuous posture assessment, and adoption of AI and ML capabilities and techniques. And then we'll sort of talk about next steps in terms of achieving that future-ready SOC. So where have we come from a SecOps point of view? I won't read all of this sort of verbatim, but you can look at this yourself. So historically, security operations centers have been data-centric, but data-centric from a single location point of view, and bringing in as much processed and unprocessed alerts into that location, managing largely with SIM technology, or if they're brave enough to build their own capability based on data analytics, but they're very much doing that in a single location with people working on that data within that environment. However, that approach no longer fits, largely because of the way that organizations have changed, particularly in the way that organizations source, procure, and use and operate software, hardware, and IT services, and looking at how that data now becomes federated and not owned by the security function. The security function becomes sort of secondary processor for that information, but they still need that information in order to orientate and act and defend their protected environments. That problem has largely been exacerbated by the emergence of cloud technologies, particularly hyperscale providers, and the capabilities that those hyperscalers now provide in terms of embedded inherent security capabilities, whether they're controls, dedicated security tooling and analytics, or whether they are capabilities that can be reused within that environment. And those our in-house security SOCs have to largely surrender some of the control that we've had, particularly in, as I said, inherent and native controls within those cloud environments to other parts of the business. So the relationship needs to stay, but security still requires access and insight derived from that data. So maintaining that sort of previously manual process and resource-heavy approach to security response and monitoring within the SOC across multiple vendor technologies, sort of swivel chair as it's been known to be called, is no longer viable in the current environment, and we're seeing significant shortages in terms of skills gap and large churn within the security operations center, and so retaining those skilled people, let alone hiring them in the first place, is becoming more difficult. So this future-ready SOC needs to be flexible, needs to be elastic in terms of both sizing, scaling, and capability, needs to adapt to changes in the market, changes to the business, and be agile enough to adopt capabilities as they come on stream, and also be able to deprecate existing capabilities quickly in order for our preference for others. So all the challenges that we've seen faced by traditional SOC design. So we've mentioned a number of these already. So with the promise of automation and AI, there are also current limitations in its adoption and potential over-adoption of AI and ML within the SOC. We've got sprawl of technologies and tools that are available to us, both in terms of detection, intervention, and being able to monitor and observe threats. We have the potential for vendor lock-in. There's the two principles, I think, one being more of a platform and an open approach, and the other being a full stack from a single vendor. Both have pros and cons, but the potential for vendor lock-in, particularly in long-term contracts, is significant. The explosion of data, the data security event data and business event data that we need to acquire within the SOC in order to observe, orientate, and act within our security operations centers. The uptick in terms of ubiquitous encryption. We're no longer able to rely on large-scale data collection from historical appliance-based tools within the network to understand information flows and what's happening within our environments at the edge and internally. Analysts are becoming there's an element of analyst fatigue when it comes to security operations. Being able to handle, triage large volumes of tier 1 and tier 2 incidents and events within the SOC needs to be addressed in order to elevate the staff within the SOC to more focused activity and interesting activity within the SOC. The cloud, as we mentioned, is a source of both benefit and problem for the SOC. So benefit in terms of being able to have a large-scale collection of information and being able to take real-time action in order to intervene and prevent threats, but it also exacerbates the problem in terms of volume and velocity of data. And all of those really lead to a complex operating environment and an increased attack surface, a fragmented perimeter, if you want, that organizations need to stay on top of in order to provide that holistic protection from prevailing threats. So a couple of key principles. As I mentioned before, we at Adarma have defined a number of guiding principles and a sort of corresponding blueprint for the future-ready SOC. So as mentioned, the SOC needs to handle large volumes of event data without incurring high volumes of ingest, processing, storage, and transfer costs. Monitor a wide variety of environments, more so than before. Embrace the concept of federated detection and response model, which we'll come on to shortly. Enable infrastructure owners that are not within the security team to subscribe to security services internally, and encourage that accountability outside of that previously centralized security operations team. So that can come into a number of factors. So whether the network team are providing information to the SOC, the network team need to take action on behalf of the SOC, or the infrastructure or platforming teams need to be able to respond quickly to requests to remediate or work around priority vulnerabilities. And there's a number of modern SOC advocates would position adopting automation, coupled that with AI and machine learning in order to reduce that dependency on analysts for repetitive or mundane tasks. Now, there's a number of barriers to adoption for AI and ML and also automation, the large percentage of that being trust in the outcome, and also trust in the ability to make informed decision making. And all of that leads to us being able to take innovative and proactive approaches to both threat hunting within our environment and also leveraging the latest technologies and techniques in order to reduce mean time to detect and mean time to respond within the SOC. So in terms of a blueprint, as I mentioned, this is a blueprint that is high level, talks at a functional level. It's not aligned to any technology vendor or solution advocated by Adarma. We have taken this blueprint and have developed our own realization of this for managed services that we provide to our customers. Now, the first principle being adopting an open architecture. And what we mean by that is being able to have an architecture that is not static or moment in time. We are able to leverage the latest and greatest technologies, having tested and validated those within our environments, but also look at the foundational building blocks of what we want to achieve from a security operations center. So the key facets being the environments that we need to protect along the bottom there. So they would be various cloud service providers, support for on-premise and legacy environments, modern network infrastructures, including SD-WAN and SASE and the capabilities that they provide. And wrapping all around all of that is identity and access management and the key insights that we can derive from that, both in terms of user behavior, but also as a key control to lock down potential threats. Moving above that, we've sort of got two paths really. One being a data pipeline that allows us to be smart about data acquisition and routing of data that from those distributed environments into the capabilities that we need. Security, continuous posture assessment, understanding the threats and their relevance to us as an organization, how vulnerable we are, the likelihood of a breach occurring within our environment, and using that information not only to inform reporting and trend analysis, but also inform decision making within the SOC. There's a degree and element of orchestration. Orchestration at a top level. We'll come on to sort of the distinction between top level orchestration and sort of distributed orchestration in a moment. And then above that, we have the traditional activities within the SOC. So threat detection from a streamed as near real time as possible data or information as possible. Threat detection from a batch processing point of view. So what we've stored, correlated, enriched within a data storage function, and also being able to perform threat hunting on top of that as well. All of that fused with threat intelligence in order for us to be threat informed in our decision making from a detection and response point of view, but also planning coverage and remediation. And then we have a number of stores within the open architecture as well. So storing of detection logic that enables us to develop detection capabilities and have that deployable across multiple downstream technologies, and doing that in a repeatable design once distribute many way. Similarly for playbooks, being able to define orchestration and response playbooks at a top level and have those distributed to the environments that we care about. So breaking that into three or four large component areas, we talked about the sort of prevalence and onslaught of large volumes of event data. If we had collected everything that we wanted to collect, we would be inundated with data, both in terms from a processing point of view, but also from a cost of acquisition and transfer point of view. So smart data pipelining is an emerging discipline within the industry, and there are a number of partners that we have in this space that enable us to be more selective around what we're collecting from environments that we're looking to protect. So having identified information that we want to continuously collect from those environments, how do we quickly determine the value of that, route it to the right locations, enrich it as close to source as possible, eliminate or remove non-valuable features from that data as close to source as possible, so we're not moving or storing data that's not valuable for us as a business point of view from a security operations perspective as well. So understanding the value of the data we're collecting is paramount, and the ability to sort of route that to the right location, store as necessary, whether that's storing for short-term operational activity or storing for long-term, either from a regulatory point of view or from a sort of a longer-term look-back perspective for operations. So aligned to that sort of collection of event data smart collection of event data from these disparate environments is the concept of federated detection and response. And this is where orchestration really comes into play. So taking into account that we have different environments that we need to observe and protect, and that those environments will operate at different levels of capability and also different levels of size and variety, is looking at how we, from a central point of view, orchestrate the collection of information and action on observed incidents or events within those environments. So all of these environments will have existing capabilities. They may have a local analytics or SIM type function. They may have a local orchestration or automation type function. They'll no doubt have controls that can collect data and also enforce actions within those environments. So looking at those different environments, again, these being different cloud service varieties, on-prem and legacy environments, sort of next generation networking environments, and identity, looking at how from a central point of view we can give those environments a degree of autonomy to observe and act on the threats that they're observing. And we do that by being able to publish detection logic down into those environments. We have a consistent approach of looking for and continuously observing specific threats. So whether they be indicators of compromise or whether they be more behavior based within those environments. They will have corresponding playbooks that we can run locally within those environments on an automation function or a fully functioning SOAR platform to be able to observe and act within those environments. What we want to take from those environments is the information that something has occurred and an action has taken place. So we're able to report on it, enrich it with other information and correlate that across different environments. This also allows us to observe within one environment and roll that across into other environments if it's applicable. So being able to push down detection logic and playbooks is one action. What we also want to be able to do is identify within those environments continuous or selected information or telemetry that we want to collect from those environments, and that would be promoted into our data pipeline. So we have three real data paths within that. One, a passive, as I said, collects telemetry. The other being more active in terms of command. We're pushing down things that we want to look for and have that returned either through that path or passively through the data pipeline. The other is being able to do continuous query within those environments. So we want to look for a particular file type or a particular executable or a particular indicator of compromise that we've been passed. Being able to ask or query those environments in real time and get the response back is critical. And all of that is orchestrated from the central function, and the outputs from that federated detection is promoted up into that central environment. What we're trying to do here is reduce the delay time between observing within an environment, promoting an event up, and having an action taken centrally and the response being pushed down. So having the confidence in autonomy with certain guardrails is what we're trying to achieve here, but also having the ability to orchestrate and direct centrally as required based on the playbook or desired outcome. So continuous posture assessment is probably one of the more complex components of the architecture that we're talking about. So we're looking at fusing a number of existing functions here. So we're looking at fusing vulnerability management, particularly risk-based or risk-informed vulnerability management, attack surface management in terms of or breach attack simulation. So we're able to exercise the environment as well as taking passive information from that environment. We're also looking at how we couple quantitative risk management or quantitative risk assessment within this environment in order for us to calculate the likelihood of a particular breach or the cost of a particular breach of a particular asset. This activity serves two purposes within the SOC architecture. One, it enables us to do trend analysis, vulnerability tracking, and also be able to inform action as we would do with traditional attack surface management and risk-based vulnerability management. But also through cyber risk quantification, we're able to look at risk and breach likelihood and use the output of that in order to inform intelligent decision making within the SOC. So whether that's enrichment of tickets, giving broader context and prioritization of an incident based on the target environment from an adversary point of view, and also looking at how we can be more proactive. So if we look at the continuous or sustained likelihood of breach around a particular asset or particular environment, we're able to be more proactive in terms of the mitigations that we're putting down. Key to this in a sort of an Achilles heel of security operations is having an accurate inventory and configuration management database. And what we're advocating here is that this process continuously updates that as a single source of authority that's able to be queried from not only this module, but also queried from other modules within the architecture through the orchestration function. So the final sort of principle of the future SOC architecture is how we look at adoption of AI and ML. And we've defined this as purposeful adoption. And what we mean by that is really looking at the benefits that the variety of AI and ML capabilities and techniques out there in the market, and potentially homegrown as well, drive value within the SOC. And what we're looking at within Adarma and also this architecture is to look at potentially all of the different varieties of AI ML that are available from different vendor types. So they may be Gemini from Google, Charlotte from CrowdStrike, or Copilot from Microsoft. All of those are embedded within the security controls and the stack that's available from those vendors. But looking at how we can leverage those in a hierarchical way that enables us to get the same information from the same sort of assistant within those environments, and really looking at how we use that to drive efficiencies within the SOC from that sort of augmented point of view. We're also looking at more sort of complex adoption of AI ML, both from a vendor source perspective and those that organizations can develop themselves. The future of that will really be around how we advance our SOCs in terms of innovation, particularly innovation in cyber defense tradecraft, and inform intelligent decision making within the SOC. So how much can we push the AI and ML algorithms in order to take defined decision trees and automate those, or run those through algorithms that enable us to go from handling a number of events through the sort of tier 1, tier 2, tier 3 processes to be able to be immediately triaged and a recommended action. So leapfrog into the take action automatically, or leapfrog into the close ticket, or leapfrog into here are a set of defined or recommended actions. Pick one, test and exercise those, and depending on the outcome, promote that to be continuously automated. So the promise of AI and ML is definitely there, but from a cautious perspective, looking at what you're really trying to achieve from a SOC point of view, or security operations point of view across the business, and selecting the correct AI ML algorithms, leverage what the vendors are doing, but looking at it at that sort of purposeful implementation within your environment. We'll dive deeper into AI ML and the other capabilities that we talked about, or functions we talked about in the subsequent sessions, but hopefully that gave you an indication or a bit of a taste for where we're going in terms of definition of future SOC architecture from a guiding principles point of view, and also a very high level blueprint in terms of adoption. And as I said, this serves a number of purposes, whether it's validating vendor technology or vendor stacks that you're looking to work with, or validating third parties that you're looking to engage with, or indeed developing an end-to-end architecture within your own organizations.
Excellent. Sorry, James.
I was going to say thank you for listening. Any questions? And I'll pass back to Amy.
Yeah, thank you very much. There's an awful lot in there to unpack. We do have time for some Q&A, so everybody, if you would like to ask a question, either pop it in the chat or in the Q&A window there. While you're having a little think, I have a question I'd like to ask. There's been an awful lot in the media lately around the SIM market. What do you see happening? Is the definition of SIM changing? Are we seeing kind of significant consolidation in the market? What's your take on last week's announcements?
I think there are a couple of, well, from last week and also the Cisco acquisition of Splunk. I think the definition of SIM is always changing. I think the definition of SIM historically is a component element of what the SIM is right now, what the categorization of the SIM is right now. If you look at a number of analyst assessments of the SIM market, so Gartner Magic Quadrant being one, I think the vendors that are playing in that space, particularly the sort of visionaries and the sort of top quadrant, are not what you traditionally call as a SIM. So I think the definition of it has evolved to more of a SOC orientated platform. SIM-SAW, I think, is definitely a consolidation, and behavioral analytics is a consolidation. So the combination of those three things is probably the modern definition of the SIM. The announcements last week, I think there's two elements to that. One, I think, is two of those component elements coming together, so logarithm in terms of a competent SIM, and exabeam in terms of being more user and entity behavior analysis orientated, coming together to sort of create a sort of a compelling single solution or offering to the market. I think the IBM and
Palo Alto.
Palo Alto, thank you. Palo Alto is slightly different. I think Palo Alto are using that to sort of gain almost immediate market share with the installed base of IBM QRadar.
Yes, yeah, absolutely. I can see somebody furiously typing, but they haven't yet submitted their question. We'll just give them a moment. I had another one, which is why we're waiting there. You talked about, when we were talking about the data acquisition and storage piece, and a critical element being understanding the security value of the data that you're ingesting. So how do we go about defining what's got security value and that it's warrants being ingested? How's that process work?
I think we need to look at the sort of categorization of that data we're looking to collect. So whether it's from you could treat it as raw event information. So what we class as raw event information is anything from a sort of unprocessed log source. So that might be business event information, it might be security device information, it might be network telemetry. Those historically are quite noisy, and the intent there is to extract pertinent information and features from that data as quickly as possible without transferring or storing all of it. The other is pre-qualified events, so things that have been triggered by something else that we can almost take and parse and enrich into our environment and correlate with other information. The other being is almost fully qualified high fidelity events. So if we're looking at a hierarchical architecture of front-end components that we have high confidence in, we can take an incident or a defined categorized incident from those environments and again promote that almost immediately and enrich it. I think if we look at what we're looking to achieve, so looking to achieve enrichment, but also looking to achieve observabilities of certain threats. So we can look at things like MITRE ATT&CK and defend, and also to look at the sort of things we want to observe. So whether it's the behaviors or the TTPs that we're looking to observe and the data we require to do that. So having a direct correlation or relationship between data source and data collection and rules, content, detection logic is a good starting point to sort of start to prune out information that's not relevant to outcomes of the SOC or defined outcomes of the business.
Sure. Okay. And we've actually got a question along similar lines. So in terms of data pipeline, how do you best achieve data collection, ensuring coverage of useful data against becoming overwhelmed with data? Is this a case of careful filtering and understanding the log content, or is there a better method?
I think that's almost the same answer that I gave just now, right? But I think it is a case of careful filtering, but also being able to sort of continuously reassess that filtering, so you're not throwing away anything that is of value. A number of technologies, some technologies as well, are quite good in understanding both event sources and features within those event sources that aren't triggering anything within either a rule base or an analytic. So it's good to you can almost over collect and then prune, but also from an approach we can look to start out from being data driven from the beginning. So looking at the MITRE ATT&CK TTPs is a good example, and an understanding what we're trying to observe, the information that's available to us, and starting from that point of view. So we can take a top-down or bottom-up approach, really collect what we think we need and prune, or collect only what we think we need and then expand that based on increasing coverage.
Great, thank you. Okay, we have one more here. Do you think that AI and automation will potentially replace a tier 1 type job in the SOC? Is it possible that AI will lead to these kinds of impacts?
I think if we're being honest, I think that's probably where we're all trying to get to as security practitioners to be able to particularly eliminate the repetitiveness of tier 1 or layer 1 activities within the SOC. Whether we can entirely do that, I think is something that we're going to strive for, but it's going to take some time, I think. So I think the first step would be to look at how we identify the activities that are repetitive, drive efficiency and automation through those, and then look at the residual and look at how we can leverage intelligent decision making through AI and ML techniques. So we still do require an analyst to select a decision or inform that, but having that sort of human in the loop, human on the loop process, I think we can start to train and drive efficiencies within that to eliminate pretty much all of tier 1 activity within the SOC. But I will be reticent to do that because tier 1 is a good route to cybersecurity for a number of individuals. And coming up through that process to other roles is look at how we migrate that role into more training the algorithms, doing more tier 2 type activities and maintaining and enhancing that ability to eliminate what we currently understand as tier 1.
It's not as if we've got an excess of people in the industry with the skills, right? So those people will more likely be upskilled. So one more question here. What do you feel are the key milestones would be in a transformation program moving towards this architecture?
Okay, I think the key aspect of this approach, which we didn't particularly touch on, was to be able to reuse what we have currently and understand what the business is trying to achieve. So looking at how we return on investment the security controls that we've got in place and available to us now and how they fit into the security architecture, look at the broader transformation programs within the organization. So whether that be migration to being more digitally native, migration to particular cloud infrastructure, those introduce both opportunities and challenges. So I think from a milestone perspective is understand the environment you're looking to protect, what controls and capabilities you have right now, what are they going to be the sort of internal influencing factors that drive that transformation from a broader business perspective, and have that as your sort of initial milestone. So orientate around what you have now. Then I'd look at more that current position and your desired future operating state. Again, one of the principles of this approach is that you don't have to have everything. It's almost, you can break this down into component chunks and invest in those component areas and leverage what you have in existence and move to this architecture over a period of time. So understanding what you're trying to achieve is the outcome. Look at then what the delta is between what you have now and that outcome and where you need to invest. And I think by doing this and taking a threat-informed approach, particularly from a coverage point of view, allows the security stakeholders and leaders within the security organization to make representation to other business stakeholders in terms of investment in order to get to this or your interpretation of this and what you need for your business.
Excellent. I can just see somebody typing in the chat at the moment. Maybe while they're doing that, if you just want to pop forward to the final slide, James. I did just want to highlight to everybody, if you are interested in having a chat, not a sales conversation at all, but if you'd like to speak to one of our principal consultants who are all well versed in this architecture, we're offering a free 30-minute conversation with one of those people. Obviously, no strings attached. So if you would like to take us up on that, just drop an email to hello@adarma.com and the team and I will arrange that for you. And we've got somebody coming in just now. Type quick. While you're waiting, you can go to adarma.com/Future-Ready SOC and download the report, which does go into more detail and gives you those architectural diagrams, which you might be able to see a little bit better than perhaps you could on the slides. Okay. Well, look, we can reply to any other questions that come in through the chat offline. I don't want to keep everybody waiting. So thank you all very much for attending. I hope you enjoy the rest of your day, and we look forward to hearing from you. Thanks, everyone.
Thank you for listening. Thanks, everyone.